Welcome, everybody. This is Dan. This is number 16, right?
Right on. Beautiful.
Excellent. So that means we're essentially 16 weeks or 17 weeks into the pandemic and 16 episodes into Tech Talk Tuesday. So thank you for those that have been joining us from episode 1. I see some names on here that I think are at 100% with us. So thanks for joining us on this journey. And today we're going to be talking about flow applications, specifically managing peak demand on a municipal source. This was a reclaimed water source, and they had some unique requirements to fit in their peak demand. And I'm going to let Tracy kind of explain this as we get a little further. Some quick introductions. I'm Andy Humphrey, RSM for the Northeast. We have Chris Wright, VP of Sales, Tracy Shields, RSM in the Colorado and Rocky Mountain states, and Dan Conger, our National Training Manager. And another reminder for those of you that may be joining us for the first time, you can catch all of our replays on the Baseline YouTube channel. And the name of the channel is Baseline Web Training on YouTube. Again, Baseline Web Training. And they're all pretty much exactly 30 minutes long. And you can go from 1 to 16 and catch all the replays. So I think, Dan, let's have you take us from here.
Okay, cool. So you're mentioning we're talking about managing peak demand, specifically on flow. So Tracy had this really interesting site that we thought would kind of illustrate some things, and we wanted to share some of the flow challenges and the water window challenges that he was facing on this site. And essentially what happened is they got the installation done, and when they're done, the utility approached them and said, can you manage your peak demand? Can you help us manage our peak demand as well on this reclaimed or recycled water? So I'm going to let Tracy, we're going to start talking about. Let me share my screen first. We're going to let Tracy give us an introduction on the site. So Tracy, if you would tell us a little bit about this site and what's going on here.
Yeah, so this is a large city park. We've got 3 controllers on this site in 339 zones. So 339 stations. At one time when we first installed controllers, we were on pond water and a pump system that gave us about 1,000 gallons a minute that we could use. And then recently, the city utility came to the parks guys and said, hey, can we transition you guys off of the pond water and put you onto our reclaimed line, which is a big 8-inch irrigation reclaimed water line that runs through the city and feeds city properties. It feeds large HOAs, commercial properties, all kinds of irrigation water use down that line.
Yeah, it's all untreated water, right?
Correct.
Yep.
Right.
Yep,
So
all untreated water.
So it's intended only for irrigation or non-consumption, and it's the park was now the new additional person, but they're going to use a fair chunk of the water, right? So you mentioned they had 3 different controllers after the renovation, 3 controllers and 1 water source. So how did they juggle those 3 controllers and the 1 water source? What was the component they brought in for that?
Yeah, so we use a flow station for that to manage the water. 3 controllers across 1 water source.
Okay.
And this was a retrofit, correct? So
Yes.
how many controllers were on this site previously?
Initially, we had 17 controllers on this site. And with base station 3200s and substations, we took it down to 3 controllers and 1 flow station.
Nice.
And Tracy, awesome. I forgot to ask you before, how are we communicating between the controllers and the substations and the flow station?
So we're communicating through Ethernet and Ethernet radio.
Okay, so radio communication from substation to controller.
Mm-hmm.
Cool.
So they started off, what you mentioned, they started off with the pond water, and now we're going to go with this reclaimed or recycled water. Did they still have that same flow rate, or were there some changes on that?
Yeah, so that's what introduced the big challenge. And that big challenge was initially out of the gate, we were only going to get 500 gallons per minute with the same water window. So that was a challenge. We had to come in and we actually never met the water window, but we had to come in and show the public utility that we could stabilize and keep our flows from going over 500 gallons per minute, because the 500 gallons per minute ended up, that number is their peak demand at a specific time of day. And so we had to show them we could manage and stay below 500 gallons a minute for a suitable amount of time. And then just a couple of weeks ago, we graduated out of that test and into 700 gallons. But we only get 700 gallons from 8 p.m. to 10 p.m. And then we've got to drop down to 500 gallons.
Right. Because
from
I
10
think
p.m. to 2 a.m.
that seems like the even harder part, right? So your flow dropped dramatically, but then they put time restrictions on those flows.
Yes.
That's a real kick in the teeth.
Yeah.
Well, I don't know if it is a kick in the teeth. It's a challenge, though.
It's a challenge. Yeah.
So initially when you start off, so from 8 to 10, you can run 700 gallons a minute, but then come 10 o'clock, it drops down.
Yeah, drops down 500 gallons till 2 a.m. And then after 2 a.m., we can ramp back up to 700 gallons a minute. But that 10 p.m. to 2 a.m. water window there, that's peak demand for the utility. So where the city's providing water to several other users along that line, and they can't run into the situation where they're not providing the reclaimed water that these people are paying for. So
Right.
We've got to manage this large site and keep it under the peak demand.
So if you couldn't have met that, that 10 to 2 lower flow rate, you'd be messing up somebody else on their system that they've already promised to, and there would have been repercussions from the city utility. Absolutely.
Yeah. Sounds like a math nightmare and a lot of spreadsheet work in order to make that work. So how is Baseline Technology contributing to provide a solution to this challenge?
Yeah, coming up, we're going to do that. So before we go into how Tracy kind of solved this issue, I'm going to remind everybody that there's two things here that we need to manage, right? There's two limits on how you can water your site. And the first one is the flow rate, or our design capacity of our water source. So how much water is it giving us? And the other limit that we have is the amount of time that we can water. So those are the two things that we want to make sure that we're aware of and we're addressing. So, and then there's three things that, Tracy, that you had to work with to make sure that you had to solve this, to meet this challenge, to solve this problem. And the first one was to be able to manage the flow, right? So with our baseline controllers, we can manage flow at the mainline level, the control point level, or at the water source level. You can measure it, you can manage it, and then if you need to react, you can react as well. And then you can manage to a design capacity and decide if you need to shut down or bring additional zones online. So that's your first thing that you needed to be able to work with, right, was your flow management.
Mm-hmm.
So the other one was you need to be able to work with water windows. So in the controller, a water window is referring to when you can water, or when you're allowed to water, and when you're not allowed to water according to the controller. So here I've got from 12 to 6:59, it's allowed to water, but as soon as it hits 7 p.m., the water window closes, and water window doesn't open up again until 7 p.m. at night. So one of the important abilities here is that if a program is running at 6 o'clock and the water window closes, it's going to pause that program, and it won't allow that program or that zone or that program to resume until the water window opens again. So that pause is significant. It's kind of one of the keys here. But a water window could also refer to the site water window. So it could be water restrictions, or in this case, the water agency is putting some water windows on you. So that's the second component. And then the third component you needed was the control point technology. So control point technology allows you to bring in flow data, pressure data, and a master valve control that can go anywhere on the main line. And with that, you can really start doing some serious management. Now, this little guy is pretty typical. It looks like that might be a 1 inch, but this is not what you used. You used the same technology, but you used a beast like this. And this is cool. Why don't you tell us about what's going on here? What we've got installed?
Yeah. So internally, we've dubbed this the triple bypass, right? So on the right-hand side of that image, you see a smaller hydrometer there that's got a master valve and flow meter built into it, and that's a 2-inch hydrometer, and it is normally open. And then in the center of the image, we've got an 8-inch hydrometer that's normally closed. And then off on the left-hand side of the image, we've got a 4-inch hydrometer that's normally closed. And then if you see in the forefront here in front of the 8-inch meter there, you see a thread inside of that bolted on T. We've got currently have a pressure sensor mounted there, so we can see pressure on the main line as well.
So why do the bypasses here? So we've got you got a 8 inches is the main feed, and the 2-inch and a 4-inch. Why even bother putting on the 2-inch? What was the benefit of that?
Yeah. So the benefit here is the resolution when we're learning flows, and then the daily use is that's a normally open section of the main line. So we continually charge the main line, so we can do leak detection on a large main line and still see the low flow values that a small leak may have. Mm-hmm. And then it also allows for quick coupler use on that main line during the day.
So day to day, the 2-inch is always open, allowing the main line to be charged. And I think we mentioned this earlier. If they had a mainline break and the 2-inch is charged, it's going to close much quicker than that 8-inch would close if they had a mainline issue.
Yeah, much quicker. And think about the amount of water you're flowing in a piece of 2-inch pipe into that main line versus the 8-inch line. So if we've got an 8-inch mainline break, but our source is only 2 inches, we're going to do a whole lot less damage to the landscape before that shuts off than if that 8-inch meter was just running full throttle on that break.
Nice. Now, so what are the different flow rates for each leg that they planned on?
Mm-hmm. So the 2-inch meter, we will allow flows under 200 gallons a minute. Mm-hmm. So they can, when we reach that threshold of 200 gallons a minute, we open up the 4-inch meter, and then the 4-inch high-end threshold is set at 360 gallons. So when we exceed the 360 gallons, the 4-inch meter shuts off and graduates, so to speak, to the 8-inch meter. So that 8-inch meter can then take us up to the 700 gallons per minute.
There we go. Using the flow station, the control point grouping capability, that's what facilitates that function, right? And it's all real time.
Right.
It's data coming back to the controller during operation, depending on demand flow based on what programs are operating at any given time. So there's not a spreadsheet that manages this. It's all real time.
Yeah, this is not math-based flow.
It automates the process.
Beautiful.
Cool.
Nice. So we've got your control point. We've got our water windows. We've got our flow management. Here's what this looks like in hydraulics. So that bypass, this is showing the 8-inch, the 4-inch, and the 2-inch. And right now, the 8-inch and the 2-inch are open, but the 4-inch is closed. So this is a shot from pipe view, and it's showing real-time flow that's running through there, and if the valve is open or closed. So this is kind of a nice illustration that comes straight out of pipe view.
Yeah. Is pipe view, is that an application that's paid for, or is that included with Base Manager?
It's included. Yeah, absolutely.
It's included, right? So anybody can utilize pipe view to view their hydraulic structure either as a linear illustration or as a complex illustration like you see here. It is available in App Manager on the left margin in the tiles. It's called Pipe View. So if you haven't checked it out, do so.
And it is with one parameter, it's 3200 capable only.
Correct.
So got to have a 3200 platform.
Yeah,
correct.
If you're going to get into serious flow, you should be looking at the 3200 anyway. So, okay, so why don't you tell us how they got this the programming? What was some of the key components of programming here?
Yeah, so when we graduated into this 700 gallons a minute scenario, one of the things that the utility said we cannot do is we cannot go from 0 to 700 gallons a minute like now. So we've got to gradually ramp that up. So we staged our program. So at 8 p.m. when our water window is open, we start running programs. So we ramp up 4 programs. One starts at 8 p.m., then 8:05, 8:10, 8:15, and then we let the flow station manage that flow and keep us under 700 gallons a minute.
So the staggered start times bring in different programs, and that's actually a pretty ingenious way of doing a ramp up.
Yeah. So it manages demand on the entire hydraulic infrastructure and also will help manage or limit water hammer potential that could happen too with that much flow going through the pipe.
And it's probably it may be water hammer in their system, but it's probably more water hammer on the municipal side too. If you were breaking their 8 and 10 inch components, they're going to cut you off. They'll be upset pretty quickly.
Yeah.
Okay. What's the other portion of programming?
Yeah, so then at 10 p.m., we've got to drop to 500 gallons per minute, right? So we've got these 4 programs ripping along from 8 to 10 p.m. and maximizing that 700 gallons a minute. And then at 10 p.m., we've got to drop back down to 500 gallons. So we've gone into 2 of those 4 programs and closed the water window from 10 p.m. to 2 a.m. So 2 of those 4 programs go into pause when that water window closes, and then when it reopens, they can resume right where they left off.
So this program is scheduled to start at 8 p.m., starts at 8, and as soon as the clock hits 10 p.m. straight up, or 9:50, as soon as it crosses from 9:59 to 10, any zones that are running pause for that 4 hours the water window is closed, and then when the water window opens up again, boom, they're just ready to run again.
Yeah.
So they don't have to do any math. They stay away from the spreadsheets. It's all within the controller.
Yeah. And then an extra little scenario that we added to this, if you saw on that map, we've got athletic fields. So in the athletic fields, we have to get those athletic fields irrigated, but there are specific times that we can do that because softball, baseball leagues, things like that, guys are playing softball up until midnight sometimes, and then they like to hang out afterwards. So we actually have our soccer fields and our softball fields scheduled with a hard start at 2 a.m. So immediately when we can ramp back up to the 700 gallons a minute, we've got hard start times here. You can see on these 4 soccer programs right below the red square, 2 a.m., they're a hard start, and we used a priority sequence here. So all of our programs are a priority 5, except for athletics. So all of the 5s will treat each other as their equals, but the priority 4s are going to take precedence over the 5s. So at 2 a.m., the priority 4 athletic fields pauses all of the priority 5s behind it so that it can get all of its water down. Athletic fields are the most important thing in the park. And then once the athletics are done, they move back into the programs that have been paused.
So if I understand you correctly, you paused programs at 10 p.m. until 2 a.m. The window reopened, which coincided with the hard start time of a higher priority program that took precedence. They watered, and as soon as they were finished, then the programs that were paused at 10 p.m. actually resume where they left off.
Correct.
And what time of morning are we typically finishing watering?
Right now, we're bleeding into the 10 a.m. range, and we're working some back end things and filtering in some other smaller flow zones to overlap. So, yeah, we're still a work in progress, but the goal is to meet our 7 to 8 a.m. water window.
Yeah.
Awesome.
That I forgot about this slide that we have this in there, this managed by flow component, right? That's the other piece of how you're going to puzzle piece all those flows together to not exceed, come up to, but not exceed your flow. Yeah. Now you mentioned that this is a work in progress, that you're still fine tuning everything as you go along, because this is a pretty advanced flow and water window scenario. And so you sent me this report earlier, so it looks like you're getting some flow reports to find out what's going on. Is that what's happening?
So inside a pipe view, we're analyzing the flow data and pressure data across the 3 hydrometers and looking for spaces in that 700 gallon a minute ranges that we can fill with some smaller, and we'll move some programs off and let them come in alongside other programs and try and shorten that water window up on the back end.
So you're using, 99 program capability in order to segment this watering schedule so that it will optimize the available flow while respecting the peak demand requests of the utility.
Yeah.
Cool. So,
Yep.
I mean, it brings all of the technology that we've been talking about for the last, 15 episodes kind of together into one
Right.
unified scenario that's just awesome from my perspective.
Yeah, another nerd here. I'll agree. It is awesome the way it brings them all together. So if there's any one of these components, whether it was the flow management, the water windows, we had previous Tech Talk episodes that you could go back and just talk about water windows or just talk about flow management, and this is bringing all of them together. Beautiful. So I'd say it sure looks like you met that challenge of managing that peak demand while on a restricted water window. You're definitely, if you're not 100% meeting it, you're damn close, and you're definitely on the right track of meeting that. Beautiful.
Awesome.
Yeah, it's been a fun challenge too. It's been fun.
Yeah.
No
So
doubt.
if anybody's got questions as to how we're doing this or managing it, type into the Q&A or the chat, and we'll see if we can answer your question.
Yeah.
All right. What other content do we have to talk about, Dan?
This is the bulk of it. Now since we've got this slide up, let's talk about this report. So this right now, this is a static image, but we can actually click on any one of those, right? And we can get some information. So Tracy, what other information have you gotten out of this flow report?
Yeah, so mainly, we can zoom this in. You can see across the top of the chart there. We can change our date range and refresh the graphs, and then we can also go in and select to just see one day at a time, 1 week at a time, a 12-hour period, or a 1-hour period. So we can zoom resolution-wise. We can zoom all the way into 1 hour, and we can see what's our flow look like in that 1 hour. And is there time that we can fit a 30 gallon a minute zone in for 15 minutes, a smaller spray zone or something like that? So we can dig deeper by altering what we see on the chart. And then it's also going to give us a pressure reading along the chart that tells us where our pressure is at with that flow.
Right, because there's definitely a connection between flow and pressure. Not the same, but a connection between the two. Wonderful. Nice.
Yeah.
You had a question come in wanting to know if soil moisture sensors are being used on site or in this example.
Not yet, but they will be introduced.
And that would be another reason why using a spreadsheet to try to calculate this is pretty much impossible. If you want to use soil moisture sensors and you're using, let's say, upper thresholds where your run times are going to be variable based on that moisture, there's no way that you could actually crunch these numbers in a spreadsheet, you need to put in the parameters just like you've done, Tracy, so that it pauses when needed and it runs programs when needed to stay within that flow restriction, whether or not one zone has reached threshold or not.
Mm-hmm.
That's an interesting point, because if you're using soil right now, you're doing straight timed watering, or they're doing straight timed watering, right? So it's going to water every Tuesday and every Thursday, regardless of what's going on with the soil moisture content. So if we had a sensor installed, that might allow you to tighten up your water window even further, because you wouldn't necessarily need to water every single Tuesday and every single Thursday.
Mm-hmm.
You could restrict it further.
True. So got a good question. Dave Shane wants to know if Base Manager takes into account smaller submains, and if so, is there a limit to the number? That's a perfect question.
Yeah. So we can take into additional submains. So we can have 8 control points. So we could have, right now you're only using 3 control points. So we've got another 5 that we could use on a single controller. And then we can have 8, we can have submains beyond those control points without a control point. So a submain would have a mainline would have its own control point that isolates it, and then we could have a submain beyond that that doesn't have a control point, and each one of those mainlines or submains could have its own separate flow limits as your pipe structure branch.
And that, again, is a capability of the flow station. So the mainline to mainline association falls in the flow station product. The 3200 doesn't have mainline to mainline assignments. And then that's correct, Dan. You would put in the hydraulic limits of that second mainline, and you've assigned a mainline to a mainline. So you could shrink it all the way down to the submain of 50 gallons a minute. And then that particular submain would only allow up to 50 gallons a minute.
Right. Yeah. Way less capacity than that 8-inch, because we want to be able to fine tune that.
Awesome. Got another question, kind of observing the elephant in the room. Mr. Campbell asks, when you have to drop from 700 gallons a minute using the reclaimed water, couldn't you just fire up the pumps from the lake?
So no, we couldn't, because according to the city, that would cross-contaminate their reclaimed water, right? So they put backflows on their reclaimed system and severed the main line from the pump.
Wow.
So no, you cannot.
We need that mechanical air gap. Remember, where the main line lifts up, it turns, and it connects to the other one?
That's still in engineering.
Yeah.
If we could all invent that, we'd be doing something different.
Yeah, so I think depending on a utilities ordinance, you may or may not be able to do that, but in this case, we couldn't.
Yeah.
Yeah.
It is interesting that they want to keep their dirty water not so dirty, but different levels of reclaimed.
Yeah, I think part of the reasoning was they don't know what anybody could dump into the lake.
Sure. Okay.
Good point. All right. And then the last question, knowing the flow of each valve and the system design capacity, when the controller fit as many valves as possible to take advantage of the maximum system flow so the user doesn't need to determine it?
That's exactly what we're doing.
Yes,
that is managed
by flow. Yes.
Managed by flow, right.
But it's important, I think, to point out that perhaps the reason that they're asking is because we had to go from 700 to 500. And so there isn't a way, let's say, in that water source setting to just enter that data. So we're manipulating the programming to meet those requirements versus just, entering that number and telling the system between these hours only run this flow. We're having to manipulate the programming and the configuration to do it.
Yeah.
So in a way, it's
is what's created that restraint or this problem to solve.
Right.
Cool.
Nice.
All right. Well, Dan, what's on tap for next week?
Next week, we're going to talk about starting a program with start, stop, and pause conditions. So without a start time and without a soil moisture sensor. So this is some innovation uses with start, stop, pause programs.
Awesome. Thinking outside the start time.
Right.
Yeah. Who needs a start time anyway?
Right. Excellent, y'all. Well, we appreciate everybody participating. Another 30 minutes has flown by. So a lot of information, great input from you, Tracy. Thank you for taking the time to join us today as a guest speaker. Great project, great use of baseline technology. So if you've got additional questions on how all this works, make sure to contact your baseline RSM. With this recorded, you can watch it again at your leisure on the Baseline Education YouTube channel, which is, one more time, Andy?
Baseline Web Training on YouTube. Baseline Web Training. All one word.
Awesome.
Maybe, Dan, we should put a link to that on baselinesystems.com. Maybe there already is.
Already is.
So there you go. Visit our website, hit the link. Be quicker, easier.
Very cool. And Tracy, Brian's giving you a big shout out saying T-Shields in the house. So,
Nice.
That's awesome. Very good, you guys. Thanks for joining us. Go out, have a great week. Be safe and try to stay cool. Wear your sunscreen and your face coverings.
Thanks, guys. See you later.
See ya.
Bye-bye.
Bye.